now I'm looking at the ratio question. So hopefully by now you've had a read of it. You might have even had a try. You probably managed to figure out about half of it. In fact, I'd be surprised if you were having serious trouble with this question. Don't feel bad if you are. We all have different strengths and weaknesses after all. So enough chat. Let's just have a look at it. I'm going to change the numbers. So let's assume that machine 1 has the ratio 60 to 24, and the machine 2 has the ratio 200 to 80. Okay. To put this into a bit more perspective, like I said, hopefully you've read the question, but the ratio is good to bad cans. So it makes so many good cans for so many bad cans. Now, the question really kind of holds your hand in the sense that it tells you to simplify this ratio, then simplify this ratio, and it tells you which one is the better machine. It's all pretty straightforward. Simplifying ratios is a lot like factorising. You look for the highest common factor between the two numbers, the two parts of the ratio. Now, I said this to my 7 group when we were looking at ratio the other day. If you divide by a highest common factor straight away, you're going to get to the simplest form in one step. However, if you're not 100% comfortable with that, and you do it in several steps, like say first you divide by 2, and then you notice it can be simplified again, so you like divide by 3, and then you notice it can be divided by 2 again. As long as you end up at the right answer, it doesn't matter how many steps you take. Yeah, true, it's more efficient to do it in one step, but if you're not comfortable with this kind of thing, look, if both the numbers are even, you know you can divide by 2 for a start, right? You can definitely do that, so go for it. Anyway, the way I like to explain it is, let's look at this first ratio. Which times table do the numbers 60 and 24 both pop up in? Well, they both pop up in the 1 times table, obviously, but everything pops up in the 1 times table, so that's just stupid. Right, they're both evens, they pop up in the 3 times table. 2. 2 times table. They both pop up in the 3 times table, because 20 times 3 is 60, and mental blank, 8 times 3 is 24. Yeah, that's right, good, excellent. I haven't let myself down. 4 times table? Yeah, they do. 6 times 4 is 24, and 15. Yeah, 15 times 4 is 60, so there we go. The 5 times table, obviously not. 6 times table, 10 times 6 is 60. And what else we got? Yeah, 6 times 4 is 24. So they both pop in the 6 times table. 7, I don't think so. 8, no. 9, no. 10, no. I'm thinking they might pop up in the 12 times table, because 2 times 24 is 12, and well, half of 126, so 5 times. Let's divide by 12, because like I said, if it turns out it can be simplified again afterwards, it doesn't matter. We just do it. As long as we end up with the right answer eventually, it doesn't matter. Okay, so let's try dividing them both by 12. 60 divided by 12 is 5. Let's turn bold off. 5. 24 divided by 12 is 2. So there we go, we get the ratio 5 to 2, and we know that that can't be simplified anymore, because well, the reason I know is because 5 and 2 are both prime numbers, but hopefully you're looking at that, and you're thinking, no, there is no whole number that I can divide both those numbers by to make it any simpler. It's really important with the whole numbers. You don't use decimals and ratio, because if you did, you could just keep going forever. You could just divide them to make the numbers smaller and smaller and smaller. So there'd still be the same balance between the numbers. For example, 0.5 to 0.2. There's still the same relationship between those two numbers, but where do you stop? You could just keep dividing them and make them smaller. You could keep dividing them by 10 infinitely. So, whole numbers only. Now let's look at the second. So let's just label that actually. Machine 1. Now we look at the second ratio. 200 to 80. Now, I'm pretty sure, just looking at it, that 20 is going to go in. But what I'm going to do is, just to prove the point that it doesn't matter how many steps you take, I'm going to divide by 10, because I know I can do that. So 200 divided by 10 is 20. 80 divided by 10 is 8. Okay? So just to keep track, that was me dividing by 10. Okay, now they're both even, so I know I can divide by 2. So I'm going to do that. So I'm going to divide by 2. So 10. There's probably some of you screaming out now like, oh god, why didn't you just divide by 4? But I'm just trying to prove a point that it doesn't matter what you do. You can take little baby steps and get to the same answer, and that's fine. I'm noticing they're both even numbers again, so I'm going to divide by 2 again. 5, 2. You know, I could have sworn that one of these ratios was meant to be 5 to 3, so I might have made a mistake somewhere. I'm just going to check something actually, but it might be that I just had a mental slip. So, and that ratio can't be written any simpler. Machine 2. So that actually, they both have the same ratio. So all that means, just bear with me, that means that they actually perform at the same efficiency because they make, at the end of the day, they make the same number of good cans to bad cans. Let me just check something first. I just want to make sure I haven't made a mistake. Divide by 24, 3 1/3, 200, divide by 60. No, it's okay. Both of those ratios are the same, actually. Alright, cool. So I just made a little mistake when I prepared this in that I picked two machines that actually have the same ratio. All that tells you is machine 2 has made more overall in a same amount of time, but actually, for every 5 cans machine 2 makes, it makes 2 bad cans. Machine 1, for every 5 good cans it makes 2 bad cans. Which is pretty poor when you think about it, but they actually operate at the same efficiency. It's just that machine 2 is able to make more in the same amount of time. Right, so that's simplifying ratios. The second part of the question. Here we go. Machine 1 was still producing good cans and faulty cans in the same ratio. The machine was running for 12 hours. That's useless information from what all I can gather. That's just trying to sidetrack you. Because at no point during the question does it talk about cans per hour. It just talks about on a particular day. So don't let that confuse you. Unless it's this... I bet it's going to be the same thing, that like you're meant to use it, and it's like the isosceles trapezia, that it's an assumption, but listen, if you're in my class, don't worry about that. It's very poorly written. Okay, so it produced 125 faulty cans. How many good cans were produced? Alright. Let's work on the ratio that I made up, not the one that's in the question. Can't stress that enough. This is not the right answer to the project. This is just my example. So we found that machine 1 and machine 2 had the ratio 5 to 2. Alright, it produced 125 faulty cans. Right. For every 2 faulty cans, there's 5 good. Alright, so it's like question mark 125. That's what we're trying to find, that part of the ratio. Now, there's loads of different ways you could do this, really. I've shown... I'm sure you figured out by now that I teach 2 Year 9 classes. I've shown one class one way how to do it, and I've shown another class a different way to do it. I'm going to show you the simplest way to do it. And then if you know a different way, you can use that way. Okay, now comparing these two ratios, you can see that 2 parts is the same as 125 parts. So 2 parts is like 125 bad cans. So that means that 125 divided by 2 is going to be 1 part. Alright? So I can't believe I'm using a calculator for this. I'm so lazy today. 62.5. So that means that 1 part is 62.5 bad cans. Okay, so if it made 125 bad cans, you do 5 times 62.5. Got this really bad feeling in the back of my head right now that this is only making sense to me. So I don't really like this example very much. I'm going to come up with a different one that's sort of the same, okay? Yeah, that's what I'm going to do. Alright, money, that's a good one. you're getting some money split out between two people in the ratio 10:3. Let's say it's Fernando and Alfonso Ramirez. Yeah, alright, okay, Alfonso gets £150. How much does Fernando get? So, if you haven't gathered already, that's Alfonso's share, and that's Fernando's share. What the ratio is telling is for every 10 parts, Alfonso has 3 parts. For every £10, Alfonso has £3. That's like another way of thinking about it, okay? You could also think 10 parts compared to 3 parts, alright? We know Alfonso has 3 parts. We also know he has £150. So 3 parts is 150. So 1 part must be 50. That's just logic, right? If 3 parts is 150, 1 part has to be 50, okay? Okay, so if 1 part is 50 and Fernando gets 10 parts, do 10 times 50, which gives 500. So in that case, Fernando gets £500, whereas Alfonso only gets 150. Poor Alfonso. Exactly the same kind of logic with this last part, okay? Hopefully by now you've figured out the ratio for machine 1, the actual ratio, not that 5:2 one. That was random, okay, for this example. You found the one on the project, and you compare the bad part of the ratio to 125 faulty cans, and you work through it just like you did here, alright? If you're still not sure, don't be afraid to come and see me, okay? But the question isn't as hard as it sounds. If anything, I've overcomplicated it, alright? Good luck.